Hello folks, welcome back and welcome to section 3. In this section, I'm going to talk about Redshift objects. So let's take a look at the agenda. So I'll start with how to query a database and database objects in Redshift. Then we'll take a look at various data types in Redshift and then some details like how do you create database schema, table, view. These are Redshift objects. We'll also see show command and load a small sample data, and using that sample data we'll be doing all the hands-on. I'll be providing you this small sample data in the Google Drive. I'll also show you that at the end of this section where you can find the data, commands, etc. in Google Drive. You'll also take a look at transaction, cursors, SQL functions, various DML operations. So the flow is not going to be like this, but I'll be covering all these things in this particular section and more. The reason that I could not provide everything because otherwise the agenda would be pretty big, because this section is going to be pretty big actually. All right, now before going into talking about Redshift and its objects, I just wanted to tell you about the relationship between Redshift and PostgreSQL. So if you are from database background and if you know what PostgreSQL is, you will see few commands and queries and syntaxes are similar to PostgreSQL. The reason is because Redshift is a fork of PostgreSQL. It is based out of PostgreSQL. So AWS took the open source code of Postgres and then they created Redshift out of it. So that's why some of the basic commands syntaxes are same, but that's all. The lot of features, lot of things that are not same in Redshift and Postgres. So let's take a high level look at those things. The first one is very important. Redshift is meant for OLAP data stores or online analytical processing and data warehousing systems, whereas Postgres is meant for OLTP data stores or operational data stores. So these are completely different. We cannot use Redshift for OLTP use and we cannot use Postgres for analytical purpose. The next one is, which we already talked about, Redshift is columnar storage and Postgres is row-oriented storage. It makes sense because Postgres is an OLTP or operational database. It is meant for OLTP transactions and OLTP use cases. So that's why PostgreSQL is row-oriented and Redshift, as you already know, is columnar storage. Now there are some features which are not supported in Redshift, Postgres features. Again, this is a very high level list. It's not detailed at all. The reason I do not want to go into details because a lot of you might not know Postgres at all. So that's why I do not want to make this talk about Postgres. So just a high level overview. The first thing is Redshift does not have any indexes, whereas Postgres has a lot of indexes. Because Redshift is a columnar storage, we do not have any index in Redshift. The reason being that the purpose of index is actually filled by columnar storage and zone maps. The next one is table partitioning. So in Postgres, we have something called table partitioning. There is range partitioning, hash partitioning, and list partitioning. Redshift does not have those, but Redshift has something called distribution, which we'll talk about later on, which is similar to hash partitioning is in Postgres. Triggers are not supported in Redshift. There is no triggers in Redshift. There is no full text search in Redshift, but Postgres has full text search using inverted indexes. There are some data types and functions in Postgres which are not supported in Redshift. So this is the high level overview of Redshift versus Postgres. Again, I mean, Redshift is based out of Postgres, but the divergence is a lot more as Redshift is meant for data warehousing systems. You have already seen that I had created a cluster. Again, I have the cluster up and running now. You might have created a cluster on your own also. But the thing is that how do you query data in that cluster? So as it is a data warehousing environment and it is relational database, of course you'll have to query records, query data in your data warehousing systems. So how do you do that? There are a lot of options available. The first one is JDBC. Java database connectivity. So using JDBC, you can actually connect your Java code to a Redshift using JDBC strings. You can use Python programming language and other programming languages also. I know Python, so that's why I'm talking about Python here. I do not know Java, and I'll be showing you Python code only. If you are new to Python, please go through the optional basic course on Python. Then you can use ODBC also, which is Open Database Connectivity. It is mainly used for command line interfaces. And based on ODBC, we have RSQL or Redshift SQL. This is a CLI or a command line interface meant for running Redshift queries only. Then we can use Redshift data APIs. So data APIs are essentially querying Redshift using API calls. So you do not have to make connection to the database. You do not need any database connection as such. Instead of making a connection to the database, you will use an API to query data out of Redshift. Then there are a lot of third-party tools available. Third-party tools, BI tools are also available like Power BI, Tableau, Looker, Sysens, QuickSight, which is AWS's own service. Then SRSS, which is Microsoft SQL Server's reporting tool. So we have this Redshift cluster, and let's say we have a client machine. The client machine would connect to the Redshift cluster. So in our case, we have created the Redshift cluster in a private subnet, and what we'll do is that we'll launch an EC2 instance in public subnet, and we'll use that EC2 instance to run Python codes, RSQL, and data APIs to connect to the Redshift cluster and run queries. Apart from these, we can also use QuickSight, which is AWS's own tool, and Redshift Query Editor V2, which is available in the Redshift console itself. In the next few videos, I'll talk about RSQL and Query Editor V2, how you can install RSQL and how you can use RSQL to query data in Redshift. Also, how you can use Query Editor V2 to run SQL queries in Redshift. In the last slide, I introduced a new term called database connection. So what is a database connection? So let's say you have this database server. Again, it can be any database server. It can be Postgres, MySQL, Oracle, DB2, SQL Server, Redshift, Teradata, Exadata, Greenplum, whatever. It does not matter. It can be any database server which is relational database. So what happens is that we want to make connection to the database server so that we can communicate with the database. So what a connection is nothing but a communication channel between a client machine and a database server. A client machine might have a command line interface or a program running. Either the command line interface or the program would make a connection to the database server, and using that connection, it will send SQL queries, and the queries would be executed in the database server and the results would be sent back. Now, these are all TCP connections or TCP communication channels. And that's what a connection is. It's a way of communication to the database server. In our case, the database server is Redshift. So let's say this is our first client machine, and maybe this client machine is running a program, or there's a database administrator who has logged into this client machine and he or she wants to make a connection to the database. In either of the cases, a connection has to be made, and one program can make multiple connections, or from the same client machine you can actually log into the or connect to the database servers multiple times using a command line interface. So in each case we can have one or more connections from one client machine. But what happens when a connection is requested? Whenever there's a connection request going out from the client machine, a socket would be opened both on the client machine and the database server. So these are all network sockets, and there would be processes and threads, or basically programs, that will be handling these sockets in your operating system. Now, once these sockets are opened, then a TCP communication channel would be opened using these sockets. and the SQL requests would be sent over these communication channels. The SQL would be executed here and the result would be sent back to the client machine. Now let's say the same client machine wants to open another connection. So another socket would be opened at the client machine for sending the request, and the database server would also open one more socket, and then the communication channel would start. So if you see, each socket has an overhead because it has an associated process or thread or program running in the operating system. These processes or these sockets are taking server resources like CPU and memory. Now this is one client machine. I'm showing you only two connections. Obviously there can be tens or even hundreds of connections from one client machine. Imagine you have another client machine, so it will be the same. Let's say client machine 2 is sending hundreds of connections to the database server. The client machine 2 would open sockets in its own machine, and then the database server would also open socket, and then the communication would happen via that network sockets. Same is the case with other or multiple client machines. And there can be sockets in database servers which are idle, which are not basically getting used. So in that case, the database can accept more connections. So if you see, the number of sockets or the number of connections are disproportionate between client machines and the database server. Let's say client machine 1 has 100 connections, 2 has 100 connections, 3 has 100 connections. So there are total 300 connections opened by 3 client machines, but on the database server it's all 300 at one go. Here the 300 connections are distributed over multiple client machines, but in case of database, a single database server is handling all those 300 connections. In most of the cases, you'll see that a database server is way bigger than the client machines, which are running either command line programs or command line interfaces, or programs like Python, Java, etc. Now, as I told you, the more connections the database server has, more resource requirement it has, because each connection would eat up some amount of CPU and a certain amount of RAM. So this is what a database connection is. It is a communication channel between the client machine and the database server. And also connections have certain amount of overhead because these are all network sockets which are being opened, software sockets which are being opened in the client machine or the database server. And there would be one thread or process that would be handling that network IO, and that process would have CPU and RAM requirement. So if you have lots of connections coming in, of course there would be pressure on the database server. Now typically OLTP databases like Postgres, MySQL, Oracle, etc. can handle thousands of connections concurrently, meaning you can send 2000, 3000, 4000, 5000 connections concurrently to OLTP databases. But OLAP databases are not meant for handling multiple concurrent connections. I mean, it can handle multiple concurrent connections, but it should not be in thousands. Hundreds are fine. So that's how a database connection plays a role in connecting client and database server. So in our case, we have a Redshift node. We have Redshift leader node and compute node. And of course, we'll be having client machines. And from client machines, let's say we have RSQL and I want to connect to a Redshift cluster. And let's say we have another client machine wherein I'm running some Python program and I want to connect to the Redshift cluster. The socket opening is handled by the leader node, not the compute nodes. So that's how a connection looks like in Redshift cluster. So what is RSQL? So RSQL is a command line interface for Redshift. We use RSQL to connect remotely to the Redshift cluster, and we run SQL commands, Redshift SQL commands using that remote connection. It can provide you additional feature like single sign-on authentication using tools like ADFS, Active Directory Federation Service, Okta, or any SAML or JWT based identity providers. JWT is JSON Web Token. You can also describe properties or attributes of Redshift objects such as distribution key. We have not talked about it yet, so don't worry, we'll discuss it in future. sort key of a table. We can also see materialized views in Redshift, and some external tables which are being referred or created in either AWS Glue Catalog or Hive Metastore. In our case, whenever we create external tables, we'll be using Glue only because we want to talk about AWS services as much as possible. So you can use RSQL to get these type of information also. And apart from that, you can also look at something called Redshift data sharing, which is only available in RA3 nodes. Again, we'll talk about it in future, but you can actually see the properties of these features using RSQL. We have another communication tool which is called Query Editor V2. There are two versions, Query Editor and Query Editor V2. You should be using Query Editor V2 because that is the latest version and it has a lot more features than Query Editor V1. Now going forward, I'll be using either Query Editor V2 or RSQL to run commands and SQL in the Redshift cluster. So let's do some hands-on.